Hello everyone, this is Group 13 and welcome to our video presentation. Our project is titled Maglev Linear Motion Control System and is sponsored by Professor Payson Huang. Traditional motor-driven linear motion systems usually feature excessive vibration, causing dynamic error to measurements and performance. Maglev technology can solve this problem by eliminating mechanical contact between the magnetic source and the levitated object. With a well-developed control strategy, Maglev linear motion systems can achieve extremely high moving speed and high position accuracy with little vibration. As a result, Maglev technology is widely applied in transportation scenarios that demand such requirements. Currently, Maglev technology is a popular research trend that many countries are competing for, so we would like to make our own explorations into this developing field. Our project aims to design a lab-scale linear motion control system. The prototype we developed will later be used as the experimental setup for the students in VM495 Mechanical Engineering Laboratory 2 to study control theory. To tackle the design problem, our solution is divided into the mechanical system design, the electrical system design, and the control system design. Our mechanical system consists of a fixed stator and a levitated mover. Here is a rendered picture of our stator design. It is 160 mm in width, 239 mm in height, and 615 mm in length. The core of the stator design is the three electromagnets that are used to provide levitation and propulsion for the mover. The assembly of the stator starts with the electromagnets. We first installed copper coils into the grooves of the machine-processed DT4C soft iron. Then, we insert the Hall sensors into the gaps and attach them to the sensor board. The three electromagnets are installed onto the base plate using the configuration as is shown here. Finally, we add the two supports of the base plate as well as some bumper plates and stoppers, and it concludes the assembly of the stator. Our levitated object is called the mover. It is 193 mm in width and height, and 200 mm in length. The core of the mover design is the three ferromagnet arrays. The neodymium magnets are arranged in Halbach array with the magnetizing directions shown here. The aluminum alloy plates are assembled together to form the frame of the mover. When the mover is installed onto the stator, the electromagnet forces between the top magnets will provide the mover with levitation and propulsion, while the bottom two magnets will only provide levitation forces. The electrical system design mainly focuses on the PCB circuit. Here is our design of the PCB layout. The top left part is the power supply starter. The rest of the left part is the feedback loop of the power supply. The right part is the PWM output driver and current sensor. The function of the PCB circuit is to provide stable power supply for the microcontrollers, current and Hall sensors, and the electromagnets. Our requirements of different voltage supplies and large circuit draw asks for a stable power control strategy. A BJT serves as a starter of the PWM chip, whose output drives the flyback transformer by controlling a MOSFET. The transformer's 12V and 5V outputs are then fed back to the PWM chip as the control signal, as we supply 36 volts to the PCB circuit. The measured voltage output from different parts of the PCB meets our target values. The control system controls the levitation and linear motion of the mover. We implemented a control diagram in Simulink. In the first loop, our controller output the force set point given the difference between real mover position and set point position. By getting the set point current, we enter the second part of control system. This part control the output voltage based on the difference of current signal collected by Hall sensor and set point current. Due to the high complexity of this project, our prototype is still being tested and adjusted. Nevertheless, we have gained hands-on experience with Maglev technology through this project, and we hope that our work can benefit future students at JI. Thanks for watching.